Hello, everyone. We all know ECS is great at running containers reliably at scale, but it doesn't make cost decisions for you. When teams move to ECS, there's an assumption that containerization automatically makes things cheaper, almost like cost savings come for free. In reality, ECS does not optimize cost for you. It simply runs whatever resource decisions you make at scale, good or bad. Today, we are going to see how one can save cost by fixing some simple things in AWS Elastic Container Services. ECS bills you for what you allocate, not what you use, and this is where most waste starts. A task defined with 1 vCPU and 2 gigabytes of memory is billed fully, even if it runs at only 30% utilization, which is incredibly common. Right-sizing correctly, observe real usage using Amazon CloudWatch metrics. This is where the truth shows up. Focus on P95 usage rather than rare peak spikes, and reduce CPU and memory gradually, not all at once. Right-sizing doesn't just save CPU seconds and memory seconds at the task level. That's only the first win. It creates compounding savings by allowing more tasks to fit on the same EC2 instances, reducing the total number of instances required, and that's where the real money is saved. Once task sizing is under control, compute choice becomes the next big lever, and this is often overlooked. Graviton is AWS-designed ARM compute that delivers better price performance for container workloads without changing how your application works. From an ECS perspective, nothing changes. Same tasks, same traffic, same scaling behavior, just cheaper compute underneath. Because ARM instances are cheaper per vCPU and more power efficient, the compute portion of your ECS bill drops automatically with zero architectural redesign. Even with compute optimized, costs can still grow in places most dashboards don't highlight, which is why teams miss them. ECS rarely shows up as the problem on the bill. The cost usually grows around it. That growth typically happens in networking and observability. When ECS tasks run in private subnets, outbound traffic like image pulls, API calls, and log shipping flows through NAT gateways and is billed per gigabyte. Even internal-looking traffic isn't free. Unnecessary cross-availability zone load balancing also introduces hidden data transfer charges, the kind nobody budgets for. Costs come down when traffic becomes intentional, minimizing unnecessary outbound calls and avoiding unnecessary cross-AZ flows. Logs follow the same pattern. Small at first, expensive later. Container logs are retained indefinitely by default, which sounds safe but isn't cheap. High-volume logs accumulate silently and turn observability into long-term storage cost, month after month. Setting sensible log retention policies stops this cost from growing without losing operational visibility. Placement strategy is the final piece that we are going to discuss, and it directly affects how many instances you pay for. By default, ECS spreads tasks evenly across EC2 instances, which looks balanced but wastes capacity. However, bin packing changes this by filling one instance as much as possible before launching another, using what you already pay for. When fewer EC2 instances are required to run the same workload, compute cost drops with no impact on application behavior. ECS cost optimization isn't about scaling less or serving fewer users. That's the wrong mental model. It's about allocating correctly, compounding efficiency, managing edge costs, and packing workloads intentionally. Same workload, smaller bill. Today, we looked at how cost optimization in ECS really works, not by scaling less, but by removing waste. First, right-sizing, allocating CPU and memory based on real usage, not worst-case assumptions.
Second, choosing better compute, using Graviton-based instances to get better price performance for the same workload. Third, watching the edges, being intentional with networking, controlling NAT Gateway traffic, avoiding unnecessary cross-AZ flows, and setting sensible log retention policies. And finally, placement strategy, using bin packing to fully utilize instances before adding new ones. Right size? Choose better compute, watch the edges, pack efficiently. If this video helped you understand ECS cost optimization better, subscribe to this channel for more deep dives on AWS architecture, performance, and cost efficiency.